Hello everyone, good morning and welcome to the class. Am I loud and audible?
Good morning, Preethi. Good morning.
So today let's get started with the Docker. Yeah. So let's try to understand what is Docker, why do we need Docker and all of this. To understand this, let's take a simple use case. I'm sharing my screen. Blackboard. Now let's suppose there is a company which has developed some application and this application needs some specific requirements like it needs Ubuntu 16, Java 8, Tomcat 9. These are the prerequisites to work with this app. And there are different people or different users interested in this app, like let's say client 1, but he has got Ubuntu 22, no Tomcat, and no Java. Right? There is another client 2, who has got Windows operating system. He also has got Java and Tomcat. And there is another client 3, who has got Ubuntu 16, Java 8, Tomcat 9. So he has got all the prerequisites. So there might be different users across the globe, right? There might be having different infrastructure, different environments. And not that everyone will have the perfect environment that suits the application needs, right? They may be having different environments. But the point is we need to provide them with application. It's very easy to provide client 3 with application. But how about client 1 and client 2, right? Does it mean that we are able to provide or we are providing the application only the one who have the required prerequisites? Is that the case? Means does it mean that we are losing others like client 1 and client 2? Is there any way to provide the application to client 1 and client 2 without losing them? Because that's how business works, right? You should be able to provide the application with all whoever are interested. It's not that only with the people who have the supported infra. So how to handle this scenario?
Yeah, using one box that has everything, right? That's
One box?
uh, so the requirement is listed on the top. Now, I mean, we want to uh, basically, yeah, I'm just talking about the containerization concept. Uh, so you can give what they want actually, uh, putting it together in one box, something to that sense.
Okay.
All the applications what is needed shall we just give them in on one box.
Let's see how to handle this scenario, how to handle this client 1 and client 2 without loss. Because it's very important that we should be able to provide the application with for everyone, right? Also, it's not that everyone can change their infrastructure to use your application, right? So how to handle these clients without losing them, how to make business, right? That's where comes, there are multiple solutions to this problem statement. There are multiple ways we can handle this. One is through virtual machines. If you know virtual machine, create a virtual machine like Ubuntu, put the application, Java, Tomcat, everything there, and share the VM. So VM solve the problem. That's how it's been done till a few years back. Right? Create a VM, put everything on the VM, whichever the app needs, and that's all. That takes care of. So the similar thing can be also done through containers. Containers also solves the problem. Means there are two problems to this. There are two solutions to this problem. One is VMs, the other one is container. So both does the almost the same. Yes, both solves the problem. You create a container with all these requirements and the application should work fine. So when we say both does the same or both solves the problem, we may be having a question like when to use VMs, what are containers, like when to go for containers, what is the difference? We will talk about them, but before that, let me tell you, both uses the concept of virtualization. Both uses the concept of virtualization, but in VMs, virtualization is done to the hardware, whereas in containers, virtualization is done at the OS level. Virtualization done to the OS level is called containerization. Right? What is meant by virtualization done to hardware? What is virtualization done to OS? We will discuss all of them. Don't worry. Okay. Just listen. And so virtualization done to the OS level is called containerization. So again, is what containerization replacing virtualization? Never. It's just the next step to virtualization. It is next step to virtualization. It's not replacing it. It's another concept, next step to virtualization. It's not replacing it. So, yes, this is how you have containers. Containers also help you solve the problem. But what is meant by virtualization done at the hardware, OS level, containerization? We will learn all of them to understand the differences, exact differences between VMs and containers. We need to learn their architecture. We'll go through this architecture and we will analyze all of this, right? So this is one thing. And okay, then what is Docker? See, Docker is a tool or a software which provides this containerization environment or containerization platform. Docker is a tool or a software, whatever you call it, right? If you need containerization or else if you want to run containers, you should have Docker installed and running. Simple, right? You want to run Java applications means Java should be installed. Same is the case if you want to run Docker containers, right? If you want to have Docker installed, if you want to run Docker containers, means Docker should be installed or running. Simple, right? So containers are the next step to virtual machines. But now, if they were similar, why do we need containers and how different they were? Let's see. To understand their differences, we need to understand their architecture. So let's get into their architecture now. So we'll come to this later. Yeah. See here. Yes. So let's look into the architecture of containers and VMs. If you look into the architecture of virtual machines, see this is a virtual machine. This is another virtual machine. And we are having like three virtual machines here. This is the hardware. Let's say your laptop hardware. Your host operating system means in my case it's a Windows 11 laptop. And then hypervisor. What is a hypervisor? What is a hypervisor?
VM,
Hyper
tool. VM tool.
Hypervisor is not a VM. Hypervisor is a software actually with which you can create a VM, with which you can launch, with which you can run a VM. Right? Like VMware, Oracle VirtualBox, Hyper-V, VM Workstation. These are all the examples of hypervisor softwares. So you want to create a VM means you will install a hypervisor and you will launch a VM from there, right? And if you closely look into a VM, every VM will have its own operating system. Every VM will have its own operating system, which is called guest operating system. This guest operating system can be any OS, okay, which sits above the host operating system, right? So if I want a Linux machine, I can create a Linux VM, right? VM will have the application, the binaries, libraries of the application, the operating system and all. Because every VM is having its own operating system, it can shut down, it can boot just like a normal machine, right? Got it, everyone? So yeah, that's how virtual machines work. Every VM just works like a normal machine, and because every VM is having its own operating system, it's definitely heavy, huge, and works slow, right? Also, whenever you are creating a VM, you will allocate some resources to this guest operating system, or else you will allocate the resources to this VM. Let's say you allocated 10 GB. Out of this, majority of the GB, like 8 GB, will be consumed by the OS.
I think we lost you, Preeti.
I am muted. I have a very bad throat, so I have muted. So I was just saying, yeah, a majority of the resources will be consumed by the guest operating system itself.
Ma'am, if you're not okay, we can postpone the class.
And that's fine. I'm fine. It's
Okay.
okay. Thank you. So 8 GB will be consumed by the guest operating system itself. Means majority of the resources are consumed by the operating system itself. And how many VMs you can put, that depends on how many resources you have here. Let's say I have 10 GB on my laptop. If I put 10 GB for every VM, they will not work. There should be some enough resources on the host itself. Right. So we can't allocate all the resources to VMs. Host also needs some VMs. Means you can't put too many VMs. How many VMs depends on the available resources. Also, if you put too many VMs, if it is a very tight, there will not be enough resource available for other processing, and your system performance may be degraded. Right. That's how it works. So this is the app we were talking about, like a gaming app. Let's say a company has developed some gaming app. This is the app, the binaries, libraries, whatever this app needs, the operating system. So this is how virtual machines work. And make a point here, to work with this virtual machines means if you want to run the VMs on your system, your hardware should support it, right? Means your hardware should support it, meaning nowadays all the laptops are coming with this option enabled. There will be some option called virtual technology. This should be enabled in the BIOS, in the input output. All the laptops are coming up with this option enabled. But some years back, like we used to enable it sometimes when you reboot, or some when you make any configuration changes. So basically, it's the point that your hardware should support running such VMs. Till now, did we run any VM on our laptop? Where are our VMs running? We have used some VMs,
Yes,
but
we use, yeah, the AWS is also virtual machine only, right?
database.
No, AWS.
AWS. No, AWS virtual machine of AWS is running on AWS data center. It's not
Okay.
running on my laptop. It's not consuming resource of my laptop. There, what is happening?
Mhm.
Let's say this is an EC2 instance. This is an EC2 instance. They are not running on my laptop. This host is AWS data center.
Okay, okay.
It is consuming resources from AWS data center. From my laptop, I'm just connecting. That's the advantage. So that I'm not allocating any resources from my laptop. That's the added advantage with the cloud. Got the point now, everyone? They are not running,
Yes.
they are not sitting on my laptop. They are sitting on AWS, someone else data center, which I am renting or which I am using for free in the free tier limit. Got the point, all of you. But whatever it is, that's the same concept. They're also same concept, but they are running an AWS data center. There'll be bare metal architecture, means there'll be no OS. Directly on the bare metal VMs will be installed. Of course, huge servers and all. And we are connecting them and using it. So that's the architecture of VMs. Because every VM will have its own operating system, like our AWS VM is having its own operating system. Of course, it's not running on my laptop, but here the architectural diagram is about the VMs which are running on your local machine. Whatever it is, the concept is same. Okay, fine. That is about VM. Then what is a container? Again, see, this is my laptop. My laptop has got Windows 11. And if you want to run containers, yes, install Docker, engine Docker, daemon, whatever you call it, your Docker should be running. Above that, you can have containers. Right? So this is a container. Container, container, container. So if you notice here, container is having application and the binaries and libraries of the app, nothing else. Means what is missing?
OS.
OS.
They are not having their own operating system. They are not having their own. If you see, if I allocate 10 GB to the VM, 8 GB is consumed by the guest. Only 2 for the app. See here, those that 8 GB is saved, only 2. Right? Very small, lightweight. Because they are light, they can be very fast. Sorry. Because they are light, they can be very fast. They start very quickly, they can run very quickly, they can be created on the fly. And they can work like a normal machine. But how they'll work, they don't have their own operating system. They don't have their own operating system, but they'll share the operating system of the host. This is called their host machine, host operating system, right? And because, they'll share their own their host operating system, still they can do everything like a normal machine. They can be started when you have limited resources, or when you have constraint on the resources, like a limit, some restriction on the resource, better you go for containers. And containers are very fast. They can be spinned up very quickly, right? And here you have to note containers. To use containers, your hardware need not support. You don't need to enable this virtualization option. Means virtualization is happening at the OS level, not at the hardware level, right? This is called containerization. So to work with this, yes, you need a Docker to be running. So container is nothing but, as the name says, it's a holder. It's like a pack which will have the application and the binaries of the app, nothing else. Binaries of the app and dependencies of the app means, let's say that gaming app, Java 8, Tomcat 9, Ubuntu 16. Again, you may be asking, you said there is no operating system. How can you say Ubuntu container? Right? Ubuntu container means it will not have full-fledged operating system, but the binaries and libraries of the operating system. Means, let's say minimal operating system. Right? So this is about a VM. This is about a container. Containers are lightweight. And now, can I ask you something? Can I run, let's say, okay, this operating system on my Windows? Earlier or initially, Docker was there for Linux. Later on, Docker was developed for Windows as well. Now we have Docker from Windows 10 and above. So, can I have a Ubuntu container here? Another distribution like a Red Hat container, or else can I have Windows? Which of these containers are possible? Also in VM.
All right, all
all.
of them.
Okay, here also Windows. Any other Linux distribution, Ubuntu. VMs, were all of them possible or not?
Yeah, ma'am. Yeah, I also
Means in
imagine
VMs,
you can
the
install.
guest operating system could be irrespective of the host operating system. Correct? In
Yeah.
VMs. Is that the
No,
case with containers also?
No, Preeti,
Why no? Why no?
because see the operating system, if it is using the host operating system,
Hmm.
if we are using Windows 11, then you cannot have uh, Ubuntu and Red Hat, right? Because it
Why?
is taking the
ma'am, can you repeat it what you were asking? A little bit of slack in between that.
I'm saying that if it is a case of VMs, what would be the operating system of this guest? What is a guest OS? It can be Windows, Ubuntu, Linux. All of them are possible. In VMs, this is possible. Is it also possible on containers? If my host is Windows 11, can I have Ubuntu container, Red Hat container, Windows container, or all of them possible or not?
It is possible, but need to understand why means Docker engine is handling it. How we need to know.
See, this is not possible in containers. You cannot, my host is Windows means you can run only Windows containers. Different versions are fine. Okay. Like Windows 7 or Windows 2020 server, fine. But you cannot run Linux because, like I just said, they will not have their own OS. They'll share the operating system of the host. They'll share the kernel of the host. A Linux container cannot share the kernel of Windows. Simple. So they are operating system specific, platform dependent. You cannot run Linux containers if your host is Windows. Got the point, all of you? But
Yes,
on the
yes, ma'am.
same machine, but on the same machine, let's say this is my Windows laptop. I have Docker installed. So this is the Docker host. So there you can run Windows containers. These are all Windows containers. Different versions are fine. Okay. So this is possible. But what if I want to run Linux containers? You can install a Linux VM on this. Correct? Install Docker on this. Then this becomes a Docker host. For the containers, you run here. Here you can run Linux containers. Because they will share this operating system. This is the host for them. Whereas they are sharing this operating system. This is the host for them. Making sense, everyone? Understood?
So, ma'am, this is not very much useful then, because here we can in
They were platform independent. Sorry, they were platform
dependent.
dependent. That's all. But when you see the advantages they offer, we will talk about those advantages. This is perfectly working, and this is the one we are deploying applications on. We were not deploying applications on VMs directly now. Let's suppose, take an example. You have got the address book verified. Is it that you are deploying this address book? Okay, let's talk about traditional deployment. Forget about DevOps. You have a var file. Where do you deploy it? I'm not talking about Docker or I'm not talking about DevOps things. I'm talking about how you are deploying till now. Anyone from deployment or anyone who have knowledge on it. Where are you deploying this var file?
We'll put in
on
WebLogic
the
or Tomcat
Tomcat.
server.
Server, right? VM or physical
Ye-
servers, correct?
Yeah, yeah.
VMs are
Yes,
physical servers like we did on our Linux session, right? You install Tomcat, you put it there, correct?
Yeah.
correct.
Tell me.
Yes, yes, you're right.
So this is a physical server or a VM, wherever it is, wherever the VM is running. You will install Tomcat here like we did in our Linux class. You put that var file in the web apps directory, correct? Okay, fine. I installed Tomcat, var file is working. Okay, I'll package the or I'll deploy it. Application is running. Here, let's say application, they changed some plugins in the POM file, they changed something in the next var file. Like you'll have to deploy a new var file always, right? So let's say now it's working with Tomcat 8. Next time it may be working only with Tomcat 9 because they have changed the plugins and all, correct? Agree with this?
Yeah.
Yes.
You have to
Go ahead,
upgrade
ma'am.
them, right? You have to upgrade them.
Yes.
That's one thing. So you have to take care of compatibilities of the packages your application needs. This is one thing. Second thing, is it enough if you deploy it on one single server or VM? In real time for production, let's say, is it enough if you deploy it on single server like this?
No.
No, we will have many.
We will have multiple n number of servers. How many depends on various factors like the user base, the high availability they need, and so on, so many. So let's say 10 VMs. On every VM, you have to install Tomcat. Correct? You have to check the right version. Let's say you install Tomcat 9 now. After a few days, it might be downgraded or upgraded. Application fails here. You have to sort out all of these issues. Am I correct or not? Check the compatibility of the dependencies of your application on all the servers you are running. Agree with me? Please speak up. Yeah,
Yes.
this is how you are doing.
Yes. Yes.
Today 10 servers, tomorrow 100 servers. We have to scale up on all 100 servers. You have to check the compatibility of the dependencies of your app. Let's say my app needs Tomcat. You have to check for the right version of Tomcat, or else your application may be needing so many other services. Here I just example, I'm marking only Tomcat. There might be so many things required for your app. All those you have to put right versions. That's how traditional deployment is happening, which is taking lot of time. This we discussed in our day one class. Right, on the day one DevOps, we were talking about intro. There we were talking about it. The deployment was become very slow because of this. So how to overcome this? We were talking about containers. Container is like I'm telling it coming with a pack along with the dependencies, and we say we are talking about okay how fast it is and like how the OS compatibility, the platform dependency and all. And another thing is now we are not going with this traditional approach because of so many challenges, time taking process which is very slow and all. Rather, what we are doing, earlier developers used to share that var file, but now developers, what they'll do, the way they share the application also change. They will put the var file in a container and also put the right version like Tomcat 9. Okay, let's say it needs Java 8. Like we have seen, right, address book, whenever you are packaging on everywhere, you have to install Java 8. We have already seen this scenario practically. And you are having lot of confusion, lot of difficulties upgrading it. Have you faced it or not? You already faced this challenge, correct? Whenever you are packaging. Same is the case when you are deploying. When you are creating var file itself, so many challenges you have faced to check their compatibilities, right? So, but now what developers will do, developers will put the var file, Tomcat 9, Java 8, everything in a container. Means container is like a holder, a vessel which will hold the application. Application means var file and the dependencies. And then share this share this container to everyone. They were not sharing var file so that ops teams would put the var file, they will put the dependencies, they will struggle with the compatibility and all. Rather, they were sharing the application along with the dependence. It's like a package. You run this package everywhere, be it a test prod or environment, it works seamless. You don't need to install Tomcat separately on the VM and all. Am I making sense? See, they will deploy this on some VM, of course. Yeah. But they need not install the tool separately. They'll just install Docker, run this container, C1. That's it. Same container, C1. This is, let's say, dev environment, or let's say QA, UAT, prod. Same container works seamlessly anywhere. You don't need to configure the underlying dependencies on the VM direct. You don't install it on anything on a VM. You just install Docker, run the container developers have shared. Means the way they were packaging the application changed. Earlier, they used to give this var file and their ops teams have to struggle. They have to face a lot of challenges to keep it running. But now developers will share the var by containerizing it. This is called containerization. Okay. Also, earlier, let's say they were running 10 servers. But now only 3 VMs or 3 servers are enough, because on these 3 VMs, you can run 10 containers together.
So Preeti, in this case, we
Just
just need to
give me a
have.
second, please. I'm not yet done. Let me finish. Right, I'll take up the questions in a minute. So altogether, you can run 10 containers on 3 VMs because containers are very light. They don't have their own OS. You may run 10 containers on single VM also. Of course, how many containers, it's again depends on what is inside a container. So I don't give a exact number here, but I think I could drive the point, right? So you don't need so many VMs like earlier, which is costly, which is time taking, maintenance is there, so many things, but just 3 VMs or 2 VMs, or else in place of 100 VMs, just 10 VMs. And you don't need to install Tomcat on every VM, check with the right version. No, you just run that container. Means the way of development, the way of packaging, the way of deployment, everything got changed with Docker. Docker brought the revolution. Till Jenkins, whatever we have learned, Jenkins might be used by testers also in a traditional methodology also. But Docker is the real approach of DevOps, which makes a lot of difference to the way of development and deployment. Right? Also, containers, you don't need to allocate the resources to them beforehand. You don't need to allocate CPU, memory beforehand like you do for VMs. For a VM to start, you need to allocate resources. But that's not the case with containers. They consume the resources dynamically. Right? They consume the memory, CPU dynamically. So this is how it was changing. It's not just they were light, there is much more beyond that. So when you look into that, basically it eliminates environmental differences, which is the major cause or issue which we see, right? So that's the actual or the main advantage of, one of the advantages of containers. There are many things we will talk about. Now, yes, any questions? Now, please go ahead.
Ma'am, in this case, developers always need to develop their code in the container only.
They will not develop the code in the container. They will develop the var file like we did packaging, but that will be done in the container. That's containerizing. How they will do, we will see.
Okay.
That's a different concept. That's not development process. And in some companies, or else, see, that's what in the beginning in the intro clause also I mentioned. It's not that something I mentioned so that people will take up the DevOps and they'll learn DevOps. It's the reality. The reality is, let's suppose you are a developer. You still want to be developer only. You are not attracted to DevOps. You are not interested in DevOps. Still, you have to learn DevOps. At least certain tools, at least like Docker. Because developers are not sharing the app directly to other teams now. They were containerizing it. Okay, after creating var file, then containerization comes in. Everyone have to learn it. Not only developers, testers, even they need these containers to spin up their test environments. So everyone have to learn it. Nowadays, what's happening? Yes, developers are containerizing it, but in some companies, when developers have no knowledge, DevOps teams are doing it. Containerizing is not a concept like development. Okay, it's a different concept. We are learning it here. So, of course, DevOps teams should know it. If developers don't know, DevOps teams are doing it. But there might be companies or there might be roles where they were picking up developers with Docker knowledge at least. So Docker is mandatory. Everyone should learn it. A developer with a Docker knowledge, it's like an added advantage, added skill to him. Of course, for DevOps, it's mandatory. There's no question. So if DevOps person don't need Docker, don't ask me that. It's mandatory. Apart from it, I'm talking about developers. Of course, testers. That's the reason I told you in the beginning, everyone should learn it. But at that time, we did not dig into this depth. Now it's a time to talk about this. Yes, go ahead, please.
Yeah, ma'am. Is it possible to bring that paint which you kept it drawing? I have a question there. Is it possible to bring
Okay, one
back?
second. Hmm.
Yeah, yeah. Here, ma'am. On Windows laptop plus Docker, the right side corner, you mentioned we have the Windows system in the base plus Docker, and then container also Windows. 3 containers you drawn here. So
Hmm.
it is like without license we can install n number of containers, ma'am, for Windows again.
We can. These images are like open. I mean, Docker is open source basically. So you have the operating system, like the official images available, which you can use for free. Yes.
Okay, usually on premise every system needs one licensing key in corporate world.
We
So
don't
how?
need it for Windows images. Okay,
Okay,
like I said,
okay.
see, do you remember I told you Windows container, Ubuntu container means it's not having full-fledged operating system. They'll just have binaries and libraries. Do you remember I told you means only the minimal
Yeah.
operating system.
Yeah, kernel will be in the base only. It will
Huh.
share that. Yeah.
Hmm.
Yeah.
It will share the
Another
kernel of
question.
the host.
Got it, ma'am. Another question here on Windows plus Docker. You are trying to keep
One
Linux.
second. Which one
Yeah,
you're talking about? This one?
that only.
Ah,
That only, ma'am. Yeah.
okay.
On top of it, if you want to install Linux VM, do we need hypervisor here
Yes, of
or not?
course. You need a
Oh,
hypervisor here, like Oracle VirtualBox or a VMware. So many
okay.
are there. Some hypervisor should be there.
Okay. Yeah. And ma'am, another question was like, can we create container and within that another container? Is it
No,
possible?
not possible.
Only one level, is it? Okay.
See, why it is not possible? To run a container, you need to have Docker installed. You can't install Docker inside a container. Another thing is, they will share the OS of the host. Where is the host here? It itself is not having an operating system. How can you run a container here?
Got it, ma'am. Yeah, thank you.
But that's a critical scenario called Docker in Docker. That's called DIN. That's a different thing. That is, we do that at some rare cases, which is not a best practice. That's very rare. Let's not go into it.
Okay, no problem.
Madam,
Got it,
regarding this,
everyone? Mm, mm,
madam, my question may be too early.
mm,
So we have the container C1, right?
mm,
In that we have Java 8.
mm.
Can we have another container with Java 11 or something like different version?
You can have another container. Yes, of
Another
course.
container with Java 11, right?
Yes, so many containers are there. Yes, that is C2.
Okay.
You can have it.
So, okay.
Mm.
Yeah, please continue that, madam. Okay. So if I want to make any code changes to this var file, if I make any changes to the var file, so how it will happen? Like now we have 2 containers, and now after that I want to make any code change. Let's say I want to do some code,
See, listen here.
config.
Developers are writing the code. You pull the code. You compiled it. You packaged it. Okay, this is var file. If you want to make any changes to the var file, code is changed. It's not that you are editing var file, right? New code, package it, new var file. But it's not that you are editing the var file.
Yeah. I mean to say, yeah, this way.
Yeah, now.
Yeah, now, okay, again, we need to do the container. We'll not, I mean, my question is, how we will know how many containers are there?
We will see, okay, how to containerize it, we will see.
Ma'am,
This
you
is
mean
new
to say Container is only for running the application, is it, ma'am? Can't developer can he do the development in container also?
He can.
No?
He can do it.
Oh, awesome.
He can do it.
Madam, is
It's like a
container is
system.
shareable?
See,
Yeah,
container
But
is just like a VM. Okay, like you launch a VM,
virtual
you do
VM,
something.
yeah.
You do like in a EC2 instance, we were launching it, we were doing everything there. Same is the case with container. But containers, the basic concept of container is you need a lightweight packages. Okay,
Got it.
so always we put a container, one app per container or one service per container as the best practice. Okay, but if you want, yeah, you can put anything and you can make your container so big. But that's a general practice we do. Let's say, okay, it's too early to talk about it. We'll discuss about those things. Okay, what do you do within containers? What are all the
Madam?
things we do?
Hello.
Yeah. Yes.
Madam, in the diagram, you were saying that containers is shareable. Is really containers are shareable?
No, not shareable. What is actually shareable, we will discuss. But at this point, we are not talking about images, right? So I was saying it as a container.
Ma'am, databases also we can run inside the container.
You can run. You can run anything inside a container. Any more questions?
Madam, Docker, we can run it irrespective of the operating system, right?
Mm.
Earlier diagram, there is a Windows operating system that you have it, and you are running the Docker on it. Docker is only the source code, right?
Louder, please. Louder. Docker is?
Docker is what? Hello, can you hear me now?
I can hear you, but it's breaking.
Yeah.
Docker is?
Okay. Here, Docker, you are saying that we are running irrespective of the data, operating system. Right. Here in the Docker, you have mentioned that Windows and some source code in the above diagram only I'm talking about. That is, we can run the Docker on the only in the Windows laptop. Is Docker is really specific to the Windows and the Linux, or we creating like this?
Shrikant, you have to correct some of the things you have asked. Were you there from the beginning?
Yes.
So I did not say Docker is specific to Windows, first thing. Second thing, Docker works for Windows, Linux, on multiple operating system it works. And the next question, what is the next question?
No, you have mentioned that above there is in a container W and then C. W means it is in a Windows only, right?
Windows
The
container.
container, yeah, Windows container. So
Hmm.
Windows, or is it really like we have in a Windows container and the Linux containers? In the below, if you see that container, you are talking about only the source code and dependencies.
Hmm.
It doesn't have
Shrikant,
the
got it,
operating
got your
system, right?
point. See, like I said, Windows, this also I have mentioned. See, I said Windows container will not have any operating system, but then I was saying Windows container. It means that it is not having full-fledged operating system, but the minimal operating system will be there. This also I mentioned. Windows container means this is not having full-fledged Windows operating system. Linux Ubuntu container means it's not having full-fledged Ubuntu, but the minimal operating system will be there. The binaries and libraries of the OS. That's why we are calling it as Windows container or Linux container. Understood?
No.
So what you did not understand? This is, let's say this is the bar file. This is Ubuntu container. Ubuntu container means just a minimal operating system will be there, not a full-fledged operating system with all the utilities and binaries, just a minimal. I'll show you. Don't worry. Okay, let's wait for some time. We'll go do the hands-on and you'll see those containers.
Madam,
Until
can you
then,
please
put
save
your
this board,
question.
madam?
Huh?
Can you please save this like in pen?
Which one? This one?
This one, the enter the screen, because
You can take
I
a
mean,
screenshot.
okay, yeah. Because I thought of referring this in again the later sections. That's the reason why I asked.
You can take the screenshot. Even I took the screenshot. If possible, I'll share if it is saved.
Yeah.
Okay.
Yeah, thank you, madam.
Which pen tool is you're using, Preeti? Just a
Which?
question. This pen for drawing. Which pen?
Epic Pen
Okay.
or Pen Walker. Okay. So coming to the VMs and containers. VMs, if you want to run multiple applications, like I said, right? If you have multiple applications, like you have a Java application, you have SQL. If you want to put all of them together, you can use a VM, right? But if you have an address book application, if you want to run the same address book multiple times, you can go with a container. Always the best practice is one application per container. So you put this WAR file in a container and run it multiple times. Like you can have multiple instances of them. Working with VMs are platform dependent, whereas working with the containers is platform dependent. Working with VMs is platform independent, right? Which we have discussed. And VMs consume a lot of resources, whereas that's not the case with containers. And to run with containers, you need to have sudo privileges or root user privileges. So those are few differences. You will understand the differences better when we actually step into the hands-on. And development with Docker. That's what we were talking about. The way of development changed. The way of packaging changed. See, build once, run anywhere. Means you package your WAR file within a container, you create a container, run it anywhere. Right? And they are bothered about building the containers with the code, libraries, data, and dependencies. So developers are bothered about containerizing the app. And also deployment got changed, right? You have a container means you can run it anywhere, be it dev or test or prod. So application runs seamlessly in any environment. There'll be no environmental issues. Rather, they'll be focusing on access, network, and all. If you know, this is the major thing we face in real time, right? Environmental issues. Application works in some environment, it will not be working on some other's machine. People have to spend some sleepless nights. It would be a nightmare to figure out the issue first, identify the issue, diagnose it, then fix it. It would be challenging always. But now with container, you don't have these environmental issues anymore. Right? How exactly it is, we will see with the hands-on. But got the point, all of you? And
Yes,
still,
ma'am.
if you have any questions or confusions, note down. Means make a note of it. Okay, when we go to the context, again, you can raise your queries. Right?
Sure.
So now that we understood how Docker is working, like, okay, what Docker is doing, let's talk about different Docker components. Like, see. Yeah. So if you see here, we were talking about container, right? But how is the container? From where are we getting a container? We were talking about container. Developers create a container, they share the container. But how do you get the container? You get the container from something called Docker image. What is this Docker image? Docker image is a static file, a read-only file. You can't edit an image. When you run that image, you get a container. Till now, I'm talking about developers are creating container, they share the container. They cannot share the container because container is a running instance of the image. Means let's say running version of the image. Similarly, do you know, we can't share the VMs, isn't it? If you have worked with the VMs, you might have known this. We can't share the VM. You will share that a particular file. There will be some VMX file or OVA file. So you share that file, right? Other teams will run that and they'll spin up the VM. Same is the case here. They are sharing the containers means they are not straight away sharing the container. They'll create an image and share that image. Image is a file. It can be shared. When you run that, you get a container. Means obviously developers are creating Docker image or Docker container. Yes.
Image, ma'am.
They will share, they'll create the image. They'll pack their application and create a Docker image share that image with other, like let's say DevOps teams, right? DevOps teams will run that image. They'll get the container running with app inside, app running actually. Okay, that's actually what is happening. We discuss in general. Now we are getting into the actual components. So that's what is Docker image. Okay, when you run it, you get a container. There were so many images already available, officially supported and managed by Docker. They were all stored in a registry. Where are images stored? The storage place of images is called registry. Docker Hub is a default registry, official registry maintained by Docker. Right? Already so many thousands of images were available. You can just download and use it. Let's say I need an Ubuntu. You can download and use it. But what if custom image like our address book application, enterprise applications, they will create their own images, right? How do you create their own image? From another component called Dockerfile. Okay, from Dockerfile, they'll create an image. How and all we will learn. Okay, don't worry at this point. They'll build it, create an image. Dockerfile is a simple text file with the Docker instructions. What are those Docker instructions? We will learn. When you run that, when you build it, they get an image. They'll share that image. How do they share? There are multiple ways. They can store it in Docker Hub or wherever. From there, other teams will download and run it. So this is our own image. Official image are already there on Hub. You can download and use it. Either it's official image or it's a personal image like your private images. Everything will be created in the same way. Like from Dockerfile, it will be built and created. Right? So that's what is this diagram. From Dockerfile, you get a Docker image. You can run and create a container, or else you can also store it on Hub. Other teams can download and use it. Okay, that's the meaning of it. Just introducing you different components. Practically, we will see every component. We will do hands-on and everything. How to create our own Docker file, how to build it, how to run it. Oh, so many things we will learn. Docker is very, very important and very, very interesting. People work with Docker. Okay, experienced people works with Docker without knowing the underlying concepts. They just blindly run containers without knowing the underlying concepts, which shouldn't be the case with you. Learn it properly, thoroughly. You will love Docker. You can do magic with Docker. It's a very great
Why
book.
should I depend? Why should I depend on Docker Hub, ma'am? Can't I use GitHub to store my image?
GitHub is to store the static files, source code. Images storage place is a registry, Docker Hub.
Okay, got it. Got the difference. Yeah.
This Docker file can be stored on GitHub. Docker file is a text file, like a text file that can be stored on GitHub, but
got
not
it,
images.
Okay. Got it, ma'am.
Image means it's not our images, PNG files. No, that's a different Docker image.
Yeah, OS image we call, right? It's similar to that.
Some analogy, not similar, some analogy you can draw, something like that.
Good. Yeah.
How to deploy and all we will learn. But is this page clear now? Like understood, right? This is the formula you have to remember throughout your DevOps life. Docker file, basic, fundamental unit. When you build it, you get an image. When you run the image, you get a content. This is a basic formula one should memorize throughout your DevOps career, right? That's a basic thing one should know. Okay, those components, without knowing these components, you can't work with Docker. So you'll be very much used to them. Don't worry. So yeah, this is what I'm talking about. This is the important thing. You build it, you get an image. You run it, you get a container. You can run the same image n number of times, you get n containers. 3 times 3 containers. Like 3 VMs coming from the same image. Right? how is it, how do you do and all. It will be very interesting. We'll be stepping in within few minutes there. So yeah, see Docker file, I told you, right? Text file. You write something, you build it, you get an image. You run it, you get a container. You can imagine container with a container in the transportation world. You put everything in a container, pack the container, right? Like you put everything inside the container, pack the dependencies, the application and all. So that's your container. So Docker image. What is image? What is present inside image? We will be talking about all of them. Shall we get into the hands-on now? Yeah.
Sure, ma'am.
Let's
Yep.
install Docker and let's see these things one after the other. You can use the same instance we were using till now. The same machine you can go for. Start the instance, connect to it. This is running on AWS data centers, right? You don't have a pain of providing resources, the lag, you don't face any of them. Like at least your laptop is not having that burden. You just start it whenever you want. You don't need to have backup of it. You don't need to worry about the data recovery, nothing. No, all the hard tasks for you. See, one thing, you just keep your questions, unanswered questions particularly. Let's suppose you didn't get answer to your question. Okay, some of the questions I may be saying that is out of context. We'll talk about it at a later point of time. Okay, you make sure you are reminding me. Okay, like let's say we got to that point. If it is not answered, make sure you are reminding me. Okay, make sure you're clarifying all your questions. The point is to put it in the right context. Certain things we can't discuss out of context, right? So that's the reason to asking you to put that on hold. But it's your responsibility to remind me, and it's my responsibility to clarify your questions, right? So keep that noted. Any unanswered questions, let's say you still have some questions on Jenkins, you can put them at any point of time now, like in the topics whichever are covered till now. Okay. All right. So yeah, it's very simple to install Docker. Get into it like we install Git or anything. Install Docker will do. That's all. As we go through the sessions, you will like things fall in the place. Still, if they were unanswered, make sure you are getting them clear. Okay, Docker is installed. Start Docker. Okay, Docker is started. Now you can run any Docker commands. Okay, first I would like to run the first very basic Docker command, Docker images. Docker images will list all the Docker images available on this Docker host. This terminology is important. What is Docker host?
The operating system that holds your Docker, this thing.
Yeah, the server or a VM where Docker is running. As of now, this is where Docker is running, means the EC2 instance. This is my Docker host. So to list all the images available on this Docker host, Docker image is the command. It's listing just the header, no output, because it's a fresh system. No images were there. Okay, fine. We don't have any images. I would like to run Docker run hello world. What is hello world? Hello world is the basic Docker image. It's a some Docker image. So basic Docker image means like a sample. To test whether it is working or not, you can use it. Sample image. Whenever it is running, it will display some welcome message like welcome to Docker, you have successfully installed Docker, kind of things. So I'm trying to run this, but this image is not present in my system. What happens now? Will it throw any error?
No, it will pull and run.
It will
From where
create
it will
and
pull?
run.
Let's run this and see. See, unable to find the image. It couldn't find this image. It pulled from Docker Hub, the default registry. Okay, if the image is not present locally, it will download it from Docker Hub, the default registry. And yes, it has started a container and welcome message. That's how the hello world works. And yes, it might have created a container. If you want to see the container, Docker ps minus a means Docker process. All the process will be listed. See, yes, container is created. It will have a container ID, which is alphanumeric, image name from which this container is coming. And this is the executable, I mean the command running inside. It is created 33 seconds ago, but stopped. Why it stopped, that's a different story. We will talk about it little later. So basically container is created. Every container will get the alphanumeric ID assigned by Docker daemon, Docker engine. But because we can't remember this, it has also assigned some name, a random name called naughty engel bat. Right? So this is how you run an image and you get a container. What if you run that same image again? By the way, it has downloaded, right? Now if you list it, yes, it's present. Correct? What if I run this again? What happens now? What happens now?
Created.
Again,
Other
it will again
First
ima-
thing, will it pull the image again? Will it download the image again?
no.
No,
no.
because it's already there. See here. It is not saying unable to find pulling. It's not saying that. Means it has used it. It has displayed this message and create a new container. 12 seconds. That's what I'm saying sometime back, right? From us, you can run the same image. This one, run the same image, C1, C2, C3. You can create n number of containers, right? That's what is this. And again, another name, Dreamy Carver. Again, if you run it, third container, again a random name. But if you want to give your own name of the container is C1. Again, it displays the message, new container is created, exited, but the name is C1. Means you can assign your own name to the container. Clear till this much, everyone? Yes
So Preeti,
or no?
the hello world is the image, and C1 is the name of that image that we have given
Not
by
C1 is the
ourselves.
name of the container. This
Container.
is image, this is container. This is image, this is container name.
Okay. And Docker run command will create and run the container, right? Both the things it can do.
It will create the container and your container is terminated here. Docker run will create a new container. That's all. Whether it will run or not, that's a different thing. Whether it is stopped,
Okay.
that's a different story.
Okay. Okay.
Ma'am, if I delete images, still container will work, right?
It
No,
will not
after
work.
creating container.
It will
So
not work.
images, okay.
We will see deletion also, but yeah, it will not work.
So that has a dependency, is it? Container should have the image, then only it will work. Okay.
How to delete,
Okay.
we'll see that. Okay. So basically you run see, Docker run. Do you provide image name or content? This clarity you should have. Sometimes people, what they do, Docker run, they'll do this one. What is our formula? You run an image or you run a container? Run command. Run
An
means
image.
I'm talking about Docker run. You run the image. Container will be created. So Docker run, image name always. Container will be created. If you want to assign name to the container, name flags even. Right? That's a one thing. Second thing, where is your hello world image actually? Where is your registry? This is your registry. Go to hub.docker.com. You may create again a free account. Without free account also you can use, no need an account also, but to store you need an account. So it's up to you, but you should better create an account, free account. See hello world. Hello world is an image, Docker official image. Right? It's an official image which you can try to see Docker is running or not. That's what we did. It is downloaded from you. But now you may be having a question, how is it downloaded from there? Docker Hub is the default registry. It's another component in the Docker architecture. So it's already a component in Docker architecture. You don't need to do something else for them to connect. Okay, you don't need to do, I'm repeating, you don't need to do something else for them to connect. It's a default registry. So if image is not there, it will search in the default registry, it will download from there if it is a public image. What are public images, private registries, so many things are there. One by one we'll be discussing. So let's continue. So it is a component in the Docker architecture. It will download from there. You don't need to do anything for them to connect. And anyway, they'll be communicating via REST API and HTTP protocol. You don't need to do anything for them. And any command you run, of course, till now I run just Docker run, Docker PS. You may be having Docker build, Docker push, Docker pull, Docker RM. So many are there. Any command you run will go to the Docker engine, Docker daemon. Docker daemon will perform the task. Okay. At this point, let me show you Docker architecture, which is very simple. This one. See, client, 3 components: Docker client, Docker host, Docker registry. Client is nothing but an interface with which you communicate with the Docker daemon. This is Docker host. On that you have Docker daemon. This is the component actually. That's what, right? Easy to instance is our Docker host. On that we have Docker engine, correct? And what is this client? Client is nothing but the shell, the terminal, where you write these commands like build, pull, run. Those commands will go to daemon. Daemon will perform the task. Registry is the third component, default registry. So you don't need to do anything additionally for them to communicate. What are the other registries? What are private registries? We will discuss them. If anyone having those questions, we are going to learn them. Right? So coming back, you may search any images here. Suppose I need an Ubuntu OS. I may search this way. Okay, you can read about it. I'll also show how to read this document. But now just search. Okay, you can search this way. And here the tag says Docker official image. Right? Means officially supported, managed, and maintained by Docker. Most trustworthy image. You can use it. You can see the downloads, rating, and all. Or else you can search here also. Ubuntu. You can search this way as well. Okay, you can search this way as well. And official means it will show you official. Okay. Okay, that's how you can understand the like the image, whether it is officially used or not. Right? Okay. So when you see here, you will be seeing something like Ubuntu and Ubuntu /.NET ASP.NET. What is all of this? To understand this, you should understand the hierarchy of the images. Like we were talking about the image, but where exactly the image is stored or how the image is stored. Like I was saying that the image is stored in the registry, but how exactly or where in the registry, right? How do you understand all of that? That's where you need to understand this hierarchy so that you can understand the naming convention better. We will take up from here in the next class. Any more questions in this part from anyone?
So Preeti, by default, it is whenever we run the command, let's say for example, Docker-1, it is going to the Docker hub and then it will find out the image and then give the output to us, right?
Docker-1 will first search locally. If it is not finding locally, then it will go to Docker.
Okay. And in case if we have our own image, then we need to upload it to the Docker hub and then it will give it to us like that.
You can do that also. If it's your own image, yes, you have to push.
Okay, so we need to push it on the Docker hub and then it will fetch it from there, right?
Yes.
Mhm.
Yes.
Ma'am, I have a question.
Mm.
So is Docker engine is equal to Docker daemon, ma'am?
Yes. Both are same, like whether you call engine or daemon or simply
Okay.
Docker.
Okay. So another question I have is, so how do I trust that Docker images, ma'am? Like if somebody placed it as a Ubuntu, but inside some virus application is there, if I install that, so how do I trust them? That is a genuine one?
Actually, here you will say official image means it's a genuine one, you can use it. Okay, official images were all managed and maintained by Docker. That's the first thing.
Okay.
Second thing,
That's it.
generally for your enterprise applications, you create your own images. Of course, again, the base will be this only. What is base, we will see. That second thing. And third thing, you also have vulnerability scans done on images. You can also do that to check any vulnerabilities on images.
Got it. Yeah. So if that gate is there, then no problem.
Hmm.
Yeah. Thank you.
Madam, can we see the Docker image? What are we just executed now? Hello world.
Hmm. What you want to say?
Yeah, I want to see that how that image looks like.
That's your image.
Yeah, I mean, this gives the image ID, all those things, right? But I want, I mean, is it possible to see how that image looks like? I mean,
Possible, we will see that. Okay.
oh, okay. Yeah.
We will get into all of those things one after the other. Okay, in a sequence we will go. First, we will learn tomorrow. We will learn about the naming convention of the images, the hierarchy, the Docker lifecycle, like pull, push, uh, a Docker run, running in different modes, how to keep your container active because containers are getting exited, right? We want to keep our running. We want to keep our container running. How to do that, we will see. So many things are there. Before we go and see what is inside the container, inside the image, we will do all of them in a flow, in a sequence. Right? See, I would suggest you to do the hands-on immediately in the sense before the next session, tomorrow's session. Right? If you have something on pending on Jenkins and Git, please put that on hold. Start from here at least. Do those things parallelly. Pending things, take it parallelly every day sometime. But get started from here.
Ma'am, usually by when you'll upload the video, ma'am, within how many hours?
Once it is available, will be uploaded, but sometimes technical issues or system restarts are happening, or sometimes unavailability with a hectic schedule, then it may be delayed. Otherwise, it will be uploaded once it is available. It will be available after a couple of hours, like after 10
Couple of hours. Okay.
or 9,
Sure, ma'am.
9:30.
Great. Yeah. Yeah.
Yesterday it
Ma'am,
got delayed, but will be.
yesterday's video was not there.
Please
I'm
check
unable to
now.
open.
Please check now. We have re-uploaded it. Please try again.
When I click the link you sent through email, day 14,
Hmm.
that says video unavailable, go to home, like
That's
that.
what I have re-uploaded it. Please check once again. Uploaded a wrong video, so re-uploaded it. Deleted the one and re-uploaded.
Okay, but for that I did not receive any email. I mean, re-upload also, do you send or the same link we can use?
Same link.
Same link it is not opening, man.
Same link means playlist link is same. Video link will change
Okay.
it.
Okay. I'll check. Yeah.
All of you check it. If anyone cannot still find, let me know. Thanks everyone. Have a good day. See you all tomorrow.